How's it going, class? Here in this video, we're going to cover Chapter 3, Section 2, the product and the quotient rules. I am not going to cover the proofs of these particular rules. I'm not going to cover the proof of the product rule and the proof of the quotient rule. It is contained in these slides, and you can, take your time to go over that. At the end of the day, we're just going to go over the application of the product rule and the quotient rule. And then we're going to review all of our rules. So first off, the product rule and the quotient rule, you would like to think that they're in a similar way derived from the same thing that we would use for the sum and the difference rules, but they're not. And so this first slide here just kind of shows you why the product rule does not use the same sort of format that the sum and the difference rule would. This example right here shows it. But what we're going to do is we're going to slide right over. This is kind of the derivation or the proof of the product rule, or where it comes from. But basically the product rule is this. So if you have two functions and you're multiplying them that are being multiplied by each other, and you want to find the derivative of those two functions that are being multiplied by each other, you take the first function and you multiply that by the derivative of the second function, and then you add to that the second function times the derivative of the first function. So I'm going to go through that one more time. So f of x represents the first function, g of x represents the second function. So essentially, you are going to take that first function here and you're going to multiply it by the derivative of the second function. So notice you're not taking the derivative of the first. You're simply taking the first as is and multiplying it by the derivative of the second. And then you're adding to that the second function, not taking the derivative of it here, but you're multiplying the second function by the derivative of the first. All right? And that is going to help you to calculate the derivative of two functions being multiplied by each other. So this is an example here. They're looking for, if f of x equals e times e to the x, find f prime of x. So basically what we need to do is we take the first function, which would be g, and x, and we would multiply it by the derivative of the second function, which is e to the x, okay? The derivative of, and then you add to that the second function times the derivative of the first function, so the derivative of x. So, to figure this out, these are actually some rules that we learned in the previous chapter, but the derivative of e to the x is in fact e to the x plus e to the x times the derivative of x is simply 1. And then what you can do here is you notice that there's an e to the x in both pieces here, in both terms you would call it, and so you can factor out an e to the x, and what's left is the x plus 1. So your final answer would be x plus 1 times e to the x. Okay. All they're doing here is they're now taking the second derivative. So if they're taking the second derivative, that means you're just simply taking the derivative of the original function, which is this, which is what we produced on the previous slide, and now we're taking the derivative of that again. So this now becomes your first function, this now becomes your second function. You're keeping x plus 1 and you're multiplying it by the derivative of e to the x, and then you're adding to that the second function, e to the x times the derivative of x plus 1. Okay? The derivative of e to the x is still e to the x, so this remains to be the same, plus e to the x times the derivative of x plus 1. Well, the derivative of x is 1, and the derivative of 1 is nothing, is 0, okay? That's the constant rule of derivatives there. And then, we would do the same thing. We'd factor out the e to the x, and what we would get is x plus 2 times e to the x, okay? So this is just a further application of that if we were to take the third derivative or the fourth derivative. But there's a little formula here that would help us to figure out what the successive differentiation values would be if we continued to find an additional term in this particular problem. Okay, so now the quotient rule, just like the product rule is taking the derivative of two functions that are being multiplied by each other. The quotient rule obviously would be finding the derivative of two functions that are being divided, right? So it would be f of x divided by g of x, what would the derivative of something like that be? So here we have kind of the proof and the derivation of that formula, but we're going to go right to the formula here. And you'll notice the numerator of this formula is pretty similar to that of the product rule. The only difference is we're kind of doing things in an opposite way. So here, instead of taking the first function and then multiplying it by the derivative of the second, we're doing vice versa. We're taking the second function, we're multiplying it by the derivative of the first, and then instead of adding, we're subtracting, right, the first function times the derivative of the second, okay? And then we're dividing that by the second function squared, right? And so a little bit more complicated. I gotta tell you, this is now that time when you're doing these problems, you need to be very orderly and succinct when you are writing these out. If you are messy, if you are unorganized with your steps, here in a problem like this with the product rule and the quotient rule, you're gonna have a difficult time, okay? So this is an example. We have two functions, one function here, another function here. We're dividing them by each other. This represents the first function. This represents the second function. The first step would be take the second function, multiply it by the derivative of the first, minus the first function times the derivative of the second, divided by we're squaring the second function here. So, you know, if you need help, you can follow these steps as to work through it. If we have questions on this, I can definitely cover one in class for you. This last slide here just talks about all of our formulas. So this would be a very, very key and important slide for us to copy, you know, and paste. Boom. Copy it, paste it, done. All right, now we're going to drop that right into our study guide for the final exam. All right, so the next section, 3.3, covers derivatives of trigonometric functions. We will cover that in the next video. Thanks.